Good morning, boys and girls. Today's lesson is 12-4, and that is critiquing the reasoning of others. I'm including a topic review because we're good at critiquing the reasoning. We do it all the time, every time we do a solve and share. Let's go on to the visual learning.
How can you critique the reasoning of others? Think about this question during the lesson. Ms. Kelly's class made a line plot showing how many hours each student spent watching television the previous evening. Amanda said, "No one watched TV for 3 hours." Drake said, "No, 3 of us watched no TV." Who is correct? Explain your reasoning. Think.
Oops.
What information do Amanda and Drake use for reasoning? Amanda and Drake base their reasoning on their analysis of the data displayed in the line plot. What does each X represent in the line plot?
Is each X a
Select your
student,
answer.
or is each X an hour that they watch TV? Good job.
Each X represents a student. 24 students are represented in the line plot. Think. How can I critique the reasoning of others? I can decide if the statements make sense, look for mistakes in calculations, and clarify or correct flaws in reasoning. Here's my thinking. Amanda's statement is incorrect. Her reasoning has flaws. She sees the 3 X's above the 0 and thinks that means that 0 people watched 3 hours of TV. The labels on the number line tell how many hours, and the X's tell how many students. So Amanda should have said, there are 3 people who watched 0 hours of TV. Could Amanda have said that no one watched TV for 3 1/4 hours? Select your answer.
Here's 3 1/4. You're so smart.
Yes, there are no X's above 3 1/4 in the line plot. How can you tell that the numbers in the line plot are time instead of number of people? The number line is labeled in hours.
See how useful labels are?
I sure do.
So Amanda's statement is incorrect, but Drake's statement is correct. Since there are 3 X's above the 0, he is correct when he says that 3 people watched no TV.
Now you know.
Now you know how to critique the reasoning of others.
Yay! All right, we're moving on. Renee works for a sand and gravel company. She made a line plot to show the weight of the gravel in last week's orders. She concluded that 1/3 of the orders were for more than 6 tons. What is Renee's conclusion? How does she support it? She concluded that 1/3 of the orders were for more than 6 tons. She supports it by a line plot to show the weight. So how would we go about seeing if she's correct? Well, if she says 1/3 of all the orders, we probably need to figure out how many orders there are. Let's go ahead and count the number of gravel orders, which is each X on our line plot. Did you get 12? Right, there were 12 orders. And now I need to know what 1/3 of 12 is. 1/3 of 12 is the same as 12 divided by 3. You got it. You're so brilliant. Yes, it's 4. So Renee's theory is that there were 4 orders that were more than 6 tons. Let's check. Here's 6. 1, 2, 3, 4. Yep. Renee makes sense because we checked the total number of orders and found 1/3 of them. I told you this was easy. All right, here is the topic review. The first question asks for a line plot to match the data shown. The best strategy for this is to look at the chart and just start here at the top and say 8. Okay, so I'm looking for a line plot that has, let's see how many 8s are in this data set. There's another one. Oh, 2. So my line, the correct line plot has to have 2 8s. Yep. That did not help me at all, did it? So let's look for 7.5. I have 7.5 once. Only once. So this line plot has 7.5 once. Oh, this one has 7.5 twice. It can't be that one. Oh, so does this one. And 7, oh, that was easy. A is the correct answer. And I knew it just by checking the 2 pieces of data to match. Number 2, the line plot shows the results from a survey asking parents how many children they have in school. How many parents have 2? Well, it's labeled number of children, so go here to 2. How many parents? That would be how many dots are above this number 2. Count them. I got 6. And I'm including my label. All right, onward we go. Georgiana makes a line plot of the amount of time she spent practicing her violin each day in the past 2 weeks. What is the difference between the greatest and the least time spent? Well, this is my time spent. The greatest value is 1 1/2. The least value marked on this plot is 1/2. I bet you can do that math. 1 1/2 minus 1/2 is 1 hour. And remember that difference between the greatest and the least, that data landmark is called the range. Okay, the most common, that is our mode, amount of time she spent practicing. Sure, above 3/4, I see there are 1, 2, 3, 6 dots. 3/4 has the most amount of time practicing. And here's where it becomes a little more tedious. Yeah, we have to write the equation and add up all these times. And it can be time consuming, but we're just going to go ahead and do it. We have 1/2 times 3. I have 3/4, and that was 6 times that. 6 times 3/4. Doesn't matter which order I write that in, 3 times 6/4 or 6 times 3/4 because of the commutative property. I have 1 times 3. I have 1 1/4. And I have 1 1/2. So I'm going to follow my order of operations, do my parentheses first. 1/2 times 3 is equivalent to 3/2. 6 times 3/4 is equivalent to 18/4. Plus 3 plus 1 1/4 plus 1 1/2. I'm adding fractions. I need a common denominator. I'm going to go ahead and choose my common denominator to be 4. You could go right now. I could add up my fractions that are fourths and combine those first. Let's do that. Let's make it a little easier on ourselves. If I see I have 2 fractions that have halves, so I have 3/2 plus 1 1/2. Let's add that. Then I'm only converting twice here. So 3/2 plus 1 1/2 is 1 4/2. I know that's improper, but we'll solve that at the end. Plus 18/4 plus 1 1/4 equals 1 19/4. And then don't forget my 3. Okay, so let's go ahead and change 4/2 into fourths. And that would be 1 8/4 plus 1 19/4 plus 3. 1 3 is 5 27/4. 27/4 reduces to be 6 3/4 plus the 5, 11 3/4. Georgiana spends 11 3/4 of an hour practicing violin. I feel like we spent 11 3/4 of an hour doing that problem. All right, one more problem set. Ashraf and Melanie cut rope in 2 different lengths for an art project. They made a line plot to display their data. Use that to answer the questions. What is the most common length, which is our mode, and the most common length here? If I look at my plot here, I notice I have a lot of little hash marks between 1 and 1 1/2. Actually, between 1 and 2, my number is divided into eighths. So the most common one here is 1 and 1, 2, 3, 4, 5, 6 eighths. Well, 1 and 6 eighths is not one of my options. So I look at my list and I realize that 1 and 6 eighths simplifies to 1 and 3/4. My answer is choice B. And now, of course, we have to find the total length of data. So first, let's write the equation. I'm going to look at my data chart starting here at 1 and 1/2. I have 3 times 1 and 1/2. I have 5 times 1 and 6 eighths. I'm leaving it eighths because I know I'm going to have to make a common denominator, and it's all split into eighths anyways. I have 4 of them, so that's total is 8. I have 2 and 1/8, and then I have 1, 2, and 3/8. Now you could go about this any way you want. Some of you might look at ways to combine to make it easier. We're going to go along the way that we were learning in class about multiplying mixed numbers before we left for hiatus, quarantine. 3 times 1 1/2 is the same as 3 times 3/2, or 9/2. 5 times 1 and 6 eighths is equal to 5 times 14 eighths. And 14 times 5 is 70 eighths. Plus 8 plus 2 times 17 eighths. This is going to be a monster of a numerator, but that's okay. 34 eighths plus 2 and 3 eighths. All right. So I could go ahead. I probably should change 9/2 to be 18/2. 36 eighths. Oh, I got a better idea. Let's change 9/2 to be 4 and 1/2. Watch why I'm doing this. 4 and 1/2. If I'm going to change it to a denominator of 8, 4 and 1/2 is what that is. But that really is 4 and 4/8. I did that because this would have been 36 eighths when I multiplied it. And my denominators are already going to be huge here. So 4 and 4/8 plus 70 eighths. And some of you may reduce these to be mixed numbers as we add them along the way. That's perfectly fine. It's a good strategy, actually. Plus 8 plus 34 eighths plus 2 and 3/8. Yeah, that probably would have been easier. But let's go ahead and add our fraction numerators, okay? 4 plus 70 is 74. Plus 34 is 108. Plus 3 is 111. I'm just going to make sure on my math here. 74 and 34. Okay, 108 plus 3, 111 eighths. And 4 plus 8 plus 2, I have 14 and 111 eighths. Simplifying 111 eighths, 8 goes into this once, and 31. That makes 3 and 7 eighths. So 14 and 13 is 27 and 7 eighths. That was a heck of a lot of work. I'm sure there were some shortcuts you could take to figure it out. However, that is the whole supporting it with work. You could find ways to make your problem easier. It's really about how you prefer to do it. I don't want to forget about this last question here. Is there an outlier in my data set? And no, there really is not. All my data is compiled together. Nothing stands out as being away from everything else. All right, kiddos, go ahead and do the Practice Buddy 12 for today. Tomorrow there will be no video, just simply the online assessment. A problem like this could be problemsome in the online assessment because there's lots of opportunities. Just take your time. I think it's only about 8 questions on the online. It's not for a grade, but it is important. Have a great day today, guys. I miss you.